What we lack is the information system to back our capitalist instruments like banks, the incoming capital market, other financial services like insurance need all of this information system in place before effectively delivering wealth and prosperity to our people. So, which takes me to a sustainable resource management. The developing world has land and a very large, capable youth. How we can manage this resource sustainably is through urban planning and urbanization. AI can predict traffic patterns, optimize public transportation schedules, and monitor energy consumptions in buildings to reduce waste and improve efficiency if we can build the remote sensing, land mapping, and the smart contracts in blockchain systems that I have tried to exert here. Challenges and considerations. So legal frameworks may need to evolve to accommodate AI in property transactions. The human factor remains essential, of course, in complex decision-making processes. Quality data input is essential for AI's effectiveness, necessitating improvements in data collection and management, and the availability of funding for capacity building. I personally was part of an initiative to, to start this AI land mapping project with the Artificial Intelligence Institute in Ethiopia, and there are promising ventures happening. And I also commend you to build on what you have done so far, and I encourage you to do what you have been doing for the past several years to do them in the next 4 years. This I have said before. AI and blockchain implementation is key in property transaction. That is what makes it the catalyst for the financial sector development. So this is my final slide. I know you have listened to me while I go on for my passion with AI in financial sector development. But really, what practical steps need to be taken? There are 7 steps. I think data collection and integration regarding property transaction, and especially on land records, is key. Second, blockchain implementation. Third, AI-powered decision support. 4, regulatory reforms. 5, capacity building. 6, public awareness and inclusivity. 7, continuous improvement. And I think AI is at the forefront of this endeavor. Conclusion. AI's role in formalizing property and securing land transactions has multifaceted implications for developing countries. It fosters economic growth, attracts investment, promotes financial inclusion, and facilitates sustainable resource management. Furthermore, it improves governance, reduces corruption, and contributes to social and gender equity, ultimately advancing the development agenda of these nations. And if we can implement a very successful stakeholder management, financing AI, financing Artificial Intelligence Institute for this role would not be difficult, as you can imagine, because the financial sector would be the first recipients of the benefits of this process, and they will finance these endeavors if we can do a successful stakeholder management. That's all I have to say now, Mr. Coordinator. I am open to receiving questions. Thank you.
Okay, thank you for your nice presentation, Mr. Bayu. And now it's open for comments and questions from the audience.
Please, I would love that.
All right. Anyone who can raise a question? No question at all? Is everything clear?
I must have done a very good job in that regard.
At least I have something to ask.
Please, right? Please, I am dying for it. I'm dying for it.
First of all, it's a very important research topic, leveraging artificial intelligence to address the informal property ownership and corruption challenges. in the developing world in general, and you took experiences of different countries who have applied this technology to solve the problem you raised. And yeah, you have also um, emphasized the integration of artificial intelligence solutions to the smart contract that actually will avoid these two problems you raised in your title. And you have raised like challenges and opportunities that actually drive you to raise these research questions, like legal framework issues, complex decision making, data quality issues, availability of funds, right? Do you
True.
have a fund to do this kind of solution? Really, that is one of my question.
Come again. I didn't catch your question,
And
please.
one of the opportunity you raised is availability of funds for developing such kind of solutions, right?
Yes, yes.
Did you already secure the fund, or you talk general scenario?
That's a very good question, Mr. Taklu, because
By the way,
I
I'm
know.
Dr. Taklu.
Oh, my apologies. My
I
apologies.
will
It's not
accuse you. All
uh,
right. Oh,
guilty as accused. My
all right.
apologies, doctor.
I'm joking.
So, in terms of financing for this AI in property management, I have worked with the financial service sector for the past 4 to 5 years, and I know for sure if we can do a successful stakeholder management, and I am willing to voluntarily work with you on this if if it's allowed, that the financial sector will not go anywhere if we cannot put in place a very robust and secure property management system. They know that they cannot give out loans the way they are giving out loans now. We cannot run the incoming capital market if we do not have a very secure and robust property system in place. What I'm saying is that let me give you a scenario. The capital market is incoming now to Ethiopia. Once it's up there, there will be shares transacting, shares of companies where the assets are valued in property. So how do we know the investors? How do the investors know if the properties of such and such company is secured? The data of these companies is secured in a manner that provides integrated information for decision making. That's what India has done. That's what Kenya has done. That's what Ghana
All
has
right,
done.
all right. It's good that you gathered the experiences of other countries and reviewed literatures. But how about the technical proposal for developing the solution? What will be future plan?
How to solve this?
I think the future plan in the case of Ethiopia could be the first step could be is leveraging the digitalizing initiative that's taking place in the local waradas, in the sub-cities, in cities of Ethiopia. That's digitalizing land records, taking that data set and building upon it to provide AI services in financial service sectors from that data set. The step-by-step guide that I provided at the end of my slide informs you to put in smart contracts, regulatory frameworks, and this AI remote sensing land mapping in parallel, so that we form a system where the financial service sector knows when a property goes up, they know the valuation has changed, and they can track it in real time. And people can transact from the comfort of their homes very securely properties, large assets, buildings. And we can trace that using AI-driven systems. I think the last 7 steps, I will provide the presentation to you, Doctor, so that you can scrutinize it a bit more.
All right. Thank you so much for your nice response to the issues I raised. But The audience kept silent. I don't know why. And then it's okay. Good chance for you to live safely. Have a good time. All right.
Thank you,
Then
doctor.
you can see
I look
the
forward
other
to working with you.
presentation.
Thank you.
All right. So by now, Adisu should be ready, right?
Yeah, yeah, I'm ready.
Okay. Please display your presentation and put it on a slideshow, please. Make it on a slideshow, Adisu. Adisu, are you hearing me? It is not on a slideshow. Just we see the slide.
Yeah, okay, okay.
Or you can continue.
Yeah, what about now?
Getting this in this mode.
Okay. What about now, doctor?
15 minutes then,
Okay, okay. Uh, Let
please.
me start my presentation. Okay, my name is Adisa Pobosara. I'm from Adama Science and Technology University at the Department of Power and Control Engineering. Okay, our title was regarding motion control of differential drive mobile robot using terminalized line mode. So as you can easily look at what we are going to be do simply from the title. Mean that one of our main objectives was already integrated in the title, which is concerned with finite time convergence, which is already what we are going to be seeing in terminalized line mode. So as outlined, I'm going to be cover the following main topic, which is the introduction part about the motion control of try mobile robot, assessment of problem, the modeling, because once we are going to be design this differential control system, we have to model the differential try mobile robot, and finally we are going to be see the control design with simulation and analyze. So when we say with the mobile robots, these such type of robotic vehicles can be employed in different applications, just like entertainment, military, exploration, those particularly with respect to safety and efficiency, where large number of levels going to be required. It is going to be pertain such type of application where safety, efficiency, and big workforce going to be required. So, but when we come to the model of this differential drive mobile robot, it's going to be characterized with non-harmonic function, right? We will see this one in the modeling part. Actually. Again, this dynamic model is highly linear, which is strongly coupled system, so it's very difficult to decouple. So when we come to, in general, the motion control system, actually, when we say motion control system, whenever we are going to use this differential robots in different applications, we have to control actually. Motion control system is going to be classified as kinematic motion control, mainly which can involve only kinematic model of mobile robot, but practically the dynamic model of the this system, what we call this robotic vehicle, is going to be affected system performance. So here we have already integrated both the kinematic model and the dynamic model of differential time variable. So as a statement of problem, actually we have already put on the title. So one of the main problems we have that's going to be exist in the conventional slide mode is symbiotical convergence and the chattering phenomena. So we have to overcome this symbiotical convergence which exists in traditional slide mode using what we call terminal system. So that the name terminal itself implies that uh, the convergence is going to be attained in finite time. So one of the main things that we are going to be mitigate here. So the second one is we are going to be see the performance of controller when these systems is going to be subjected to both internal and external disturbance. Again, as we have already said, that motion control system is going to be consists of kinematic control. Once can control robotic vehicle using only the kinematic model of differential drive mobile robot. So, but practically, the dynamic model of the differential drive mobile robot can affect system performance. Again, basically, one of, as we have already said, that the convergence rate and precision control system is one of things that we are going to modify. So, whenever we will able to obtain uh, final response in finite time, so convergence rate can be improved. In case of precision, again, one of the main advantages of the nice file mode is it's going to be characterized with high precision. Yes. Okay.
You are navigating the slide, by the way. You are still
Okay. Okay. Actually, do you hear me, doctor?
Yes, yes.
What about I'm navigating? So I think it's visible.
No,
right?
no. The side, the left side. It is not on
What about
slide.
now? On
Yes.
slideshow? Yeah, actually, it is already on slideshow. What about
Not
now?
with us.
Okay, let me see it again, right? But I don't know what's the problem. Okay,
Now we see literature for navigating. Yeah.
okay, what about now?
You are on now.
Ah, well, okay. Okay. Actually, as I'm already said that the paper I'm already gathered is related to the kinematic control problem, chartering problem, robustness. Again, one of the main advantage of sliding wheel control is going to be robust any external and internal disturbance. Again, whether the control system employed for the motion control is going to be linear or non-linear. Again, as we have already said, that convergence rate, accuracy, modeling of differential drive over something that we have already gathered with respect to this research work. So I think no need to go in detail on this one, right? We have already put those things on the paper. So let me go to the modeling part actually, which is consists of kinematic model of differential drive mobile robot and what we call the dynamic model. So whenever we are going to model the kinematic model, we have to put frame on the with the mobile robot. One is the system uh, inertia or world coordinate frame, and then the robot coordinate system. But here it is the posture description of differential drive mobile robot, which is consists of radius of driving wheel, the distance from center to the axle of robot, each driving wheel, distance from the center of mass of robot to the point on the center of the axle. So here, as you know, that differential mobile robots, it's going to consist of uh, two back wheel with one casted front wheel. So the back wheel is going to be done using actuator, basically DC motor. So mechanical system is going to be constrained. It's going to be characterized with. It's going to be subjected to constraint. The first one is going to be harmonic constraint, and the second one is going to be non-harmonic constraint. So, as we have already said in the introduction part, with the mobile robots, all with the mobile robots need to be subjected to non-harmonic constraint. The first one is going to be no left. When we say no left sleep, there is no uh, the direction of movement of this mobile robot is going to be the same as the wheel plane of rotation. So due to this one, there is no slip in the vertical. That's going to be the velocity along the y is going to be zero. It's going to be linear velocity along the y is going to be zero. The second constraint is going to be the second harmonic constraint is regardless to the longitudinal slip. So whenever all portion of the apply torque is transmitted to the ground, which can result the forward motion of these different drive mobile. So from this one, we have two linear velocity. That's going to be linear velocity. That's going to be linear velocity of right wheel and then the left wheel, which is the product of radius of the wheel times the angular velocity of each wheels. That's going to be right and the left wheel. So we can relate the what we call the system or coordinate system to the robot coordinate system. Reference coordinate system to the robot coordinate system using rotational matrix actually, which is rotation about it. This is actually in world frame. Differential. Okay.
On which slide are you talking? You are on slide 6 with us.
Okay. Slide 6. Right. Let me Sorry for the interruption, actually.
Okay, okay. Finish.
Let me make it.
Don't forget navigating.
Let me make it entire screen.
Okay.
What about now, Doctor?
It's the same, but
I shared.
continues changing.
Okay. The second one is going to be
It's fine.
concerned with the dynamic model of differential drive mobile robot. So here there are two types of there are two mechanisms to model any mechanical system, as we know that. The first one is going to be Lagrangian formulation, and the second one is going to be internal formulation. So here we employed the Lagrangian formulation in order to drive dynamic model of differential drive. So when we are going to use Lagrangian formulation, we have to quantity. The first one is going to be kinetic energy of this differential drive mobile robot, and the second one is going to be what we call the potential energy of differential drive mobile. So we know that this robotic vehicle is going to be travel in XY plane, so that we know that the potential energy is simply assumed to be zero. So in order to model this, the things that we are going to be drive is simply the kinetic energy of the differential drive mobile robot. So this is the kinetic energy of differential drive mobile robot. So finally, the final expression for the model of this vehicle in terms of the linear velocity and what we call the angular velocity of differential drive mobile robot, which is related to the actuator in what we call the left and the right torque, which is simply expressed as it can be seen from the slide. So let me go to the main part of this research works. So as we have already said that in this research works, we have already integrated both the kinematic outer controller and the dynamic inner loop controller. So this outer kinematic controller is going to be generate two control signals. The first one is going to be the linear velocity of differential drive mobile robot and the angular velocity of differential drive mobile robot. So these two control signal is further converted to the rotational position of driving wheel using inverse kinematics. So the inner loop control is going to be tuned. There is any error between what we call reference rotational position and the actual rotational position, which is already measured using a sensor. So this further, the actual rotational position is further converted to the what we call the linear and the angular velocity of the DDMR using forward kinematics. So the entire closed loop control system is going to be works in such a manner. So the control signal required to achieve kinematic outer loop control is already designed using Gauss switching SMS and the global fast terminal line mode. So final control signal required to achieve required to generate control signal in terms of D and omega, which is what we call linear and angular velocity of differential drive mobile robot. So that's going to be the product of IE, WD plus VD. That's going to be desired angular and linear velocity of DTMR. So in the same manner, dynamic level control design is already designed using what we call NTSMS. That's going to be non-singular terminal slide move. So most of slide moves going to be singular. They are characterized with singularity problem. So here, non-singular terminal slide move is employed in order to tune there is any rotational position of differential drive mobile robot. So final control signal required to achieve the inner dynamic rotational position control system is already designed in such manner actually. So when we come to the simulation result, this is concerned with the parameter of terminal slide mode and the desired reference trajectory, which is required to be tested in these research works. So when we come to the simulation result, this is the first figure. Figure 4 is going to be implies tracking here along three parameters what we call rotational position and translation along x and y. So, and the second figure is going to implies the control performance of inner controller. That's going to be if there is any error between the angular and the linear velocity. So the inner one is going to be tuned that one. So finally, from this differential drive mobile robot is tested for infinite trajectory starting from point 0 minus 2. So from the figure you can see that the robot's going to start initially from 0 minus 2 and finally comes to the reference trajectory. So in the same manner, if you want to see robustness of this controller, so the system will be subjected to random Gaussian disturbance and mismatching and the matching model uncertainty. So from the graph, you can see that the controller is robust. So if there is any error results in the inner position control system, so the controller will bring error back to 0. So you can see from the graph there is some character which is going to be seen as there is a little bit oscillation. So that's going to be one of the performance of controller to bring the error back to 0. So this implied that the proposed controller is robust to both internal and external disturbance. Again, from the control signal, we can easily say that there's no any chattering phenomena which can result high frequency oscillation which can affect actuator and any electronic device that's required to implement this research project actually. So when we come to the conclusion and the modeling is already done using Lagrangian formulation, both kinematic and dynamic loop control is employed to improve the performance. So in general, we can say that high precise and high convergence effect control systems already employed for this differential drive mobile robot. So the results show that both inner loop and outer loop controller is insensitive to any random Gaussian external disturbance. So the proposed controller shows high performance with good efficiency for the given circular trajectories as can be seen from the result I'm already put on the slide. So as a future work, we will further recommend the modeling which can integrate when in case where there is a sleep, further design and evaluation of application area just like welding task, painting robots, application for collision avoidance will be also pursued. And additionally, it's very interesting to develop this study which can build line control and hardware that's going to be utilized digital control system or microprocessor. So this is all about my presentation. If you have any comments, suggestions, and questions, welcome.
Okay. Thank you, Atisu, from Science and Technology University. He presented the title "Tracking of the Differential Drive Mobile Robot Using a Finite Model Controller, a Sliding Mode Controller." So, if the audience have some questions for him, I will give the chance for the audience first. Any question? Any question? Okay. Okay. So if there is a question at this point,
Okay.
may I ask you one question? At this.
My mic is mute. That's why my sound is
Okay. Okay.
everybody. So you can ask me, doctor. Okay.
The audience gets silent. So, for example, what is your key finding in this research?
Okay, that's a nice question, actually. Right. So, as I'm already said in an introduction part, actually, one of the key findings in this research work is for it what we call the problem that's going to be exist in conventional sliding mode. That's going to be one of the problems is chattering phenomena, symbiotical convergency. So here the new type of sliding mode that's proposed recently, which is called terminal sliding. We know that in conventional sliding mode, if we want to have fast convergency, we have to increase the control gain, right? Which can result high frequency oscillation, which can damage our actuators, electronic device that's going to be exist whenever we are going to be implement practical, right? So here we employed terminal sliding mode. So in terminal sliding mode, finite convergency is possible, right? So that's going to be one of the finding. Moreover, in our research works, we integrated both the dynamics and the kinematic model of differential triangle. That's the main difference in what already done so far with respect to our research works. Hello? Hello?
So yeah, thank you for your precise answer
Okay.
for the question I raised. And my second question is simulation based, right?
Okay.
What is your plan to make it practical?
Yeah, actually, one of maybe in my PhD study, I'm excited to make this practical, right?
Yeah,
Maybe one of my research area and uh, I study my PhD program. I'm trying to implement this research. Actually, in our country, you know that it's very difficult to get sensor, just like feedback sensor, uh, maybe which can use it to implement this research work practically in digital computer system or microprocessor. That's why we have skipped this research to physically implement. Maybe if we got feedback sensor, just like uh, accommodator, position sensor, uh, we can go that. But
okay.
it's all about the situation.
So thank you, Abisu.
Okay, thank you, doctor.
Another presentation. The next present will be Muhammad Said from Information Network Security Administration, Ethiopia, with the title Conflict Type Prediction using Machine Learning, in the case of Ethiopia. So if we have Muhammad with us, is the floor is open for you, Muhammad. Muhammad, unmute your mic if you are here and continue your presentation. Muhammad? Muhammad? Muhammad, please share your slide and talk. Muhammad, unmute your mic, please. Mic muted now. Unmute go.
Mr. Mohammed, slide in. We can see your slide. Please unmute yourself and start presenting. So, predicting conflict type using machine learning in the case of Ethiopia is I will try to cover those things. My name is Mohammed Hassan. My research title is conflict type prediction using machine learning in case of Ethiopia. I will try to cover those 10 points in this presentation. The first one, background. Ethiopia is experiencing various forms of conflicts over the years, including ethnic, political, and resource-based conflicts. Understanding and predicting conflict type is essential for government, policymakers, and humanitarian organizations to develop proactive strategies for conflict prevention and resolution. So, predicting conflict type using machine learning in the case of Ethiopia is a critical endeavor due to the country complex socio-political landscapes. Machine learning can play a pivotal role in this task by analyzing historical data to identify patterns and factors contributing to different conflict types. By using predictive model, researchers and policymakers can gain valuable insight to dynamic of conflict conflicts in Ethiopia. So, therefore, this study could contribute to significant to promote peace, stability and development in Ethiopia and serves as a valuable model for conflict prediction in other regions facing similar challenges. When it comes to the motivation, as we know, Ethiopia is a diverse nation with various ethnic and cultural groups, has faced complex international conflicts in recent years, posing significant challenge to stability and peace. Understanding and predicting the types of conflicts that may arise is crucial for proactive conflict management and prevention. Therefore, the study seeks to use the power of machine learning to enhance conflict prediction and enabling government policymakers, peacekeepers, and local communities to take timely and effective measures to prevent and mitigate conflicts before they escalate. By leveraging machine learning and analyzing historical conflict data, this study aims to provide a more accurate, we remind a more effective means a more accurate and data-driven approach to conflict type prediction, This prediction capability can be instrumental in informing government decision and also in informing guiding the conflict resolution efforts in the allocation of resources where they are most needed. Ultimately, the study, this study inspired to contribute to sustainable peace and stability in Ethiopia by equipping or preparing stakeholders with valuable insight to address and intricate dynamics of conflict with the country. When it comes to the statement of the problem, Ethiopia is a diverse and populous East Africa country that has experienced various forms of conflicts in recent years, including ethnic, political, resource-based conflicts. These conflicts have had significant humanitarian and socio-economic consequences, making it essential to help to develop predictive models that can help to anticipate and understand the dynamics of these conflicts. Therefore, this study seeks to address the pressing issue of conflicts within the Ethiopia context or in Ethiopia. Machine learning techniques can help to employed to analyze historical data to predict the types of conflicts. These are assisting governments, policymakers, humanitarian organizations, and peacekeepers in taking proactive measures to mitigate the impact of such conflicts and promote stability in the country of Ethiopia. This initiative not only has a potential to save lives and also reducing suffering, but also enhancing the long-term stability and development perspective of Ethiopia as a country with immense cultures, immense political movements, and immense economic significance in the Horn of Africa. The main objective of this study is to develop machine learning model to predict types of conflicts in order to improve Ethiopian economic and social stability. Specifically, data is collected from armed conflicts, location and event data that is acted by categorizing of the attribute values that is riots or protests, battles, and violence. We remind the class attribute is that is the predicted attribute is values are riots or protests, battle, and also violence against civilians. The data pre-processing also applied in this research, model development and impact assessment, that is the evaluation metrics is the effectiveness and efficiency in this study more concentrated the effectiveness of the model. In nutshell, the study aims to leverage machine learning techniques to enhance our understanding of dynamic conflict in Ethiopia, classify conflicts and provide actionable insight for conflict management and prevention of efforts in the country of Ethiopia. When it comes to the significance, this study has significant for conflict preventions that predicting conflict type using machine can help to early identification and understanding of potential conflicts and also resource allocation. Accurate prediction can guide the allocation of resources, reducing human suffering. Timely conflict prediction can lead to quicker response to crisis, potential reduction in suffering during of severity, and during of conflicts. Data-driven decision making, that is, machine learning can help to analyze vast amount of data from various sources. This study taken from the ACLED or armed conflicts location and event data. Geographical focus, the study focus on Ethiopia. That is particularly relevant because Ethiopia has experienced various forms of conflicts, and the other importance is global relevance, that is international relevance, because the study finding may have broad implication beyond Ethiopia. In summary, the study on conflict type prediction using machine learning in case of Ethiopia holds a significant potential for making a positive impact by contributing to conflict prevention, resource allocation, data-driven decision-making in regions that has faced various forms of conflict in recent years. When it comes to the summary of related work, most of previous researchers or investigators on conflict predictions and resolution predominantly relies on traditional statistical method or expert opinion. That is, most of the studies that relate with this title is investigated by the expert opinions or statistical methods. This is the traditional one, in spite of the fact that the previous investigation has a substantial commitment to appearing the direction and conducting this study, but on this era, conflict type prediction is not examined much locally in Ethiopia, especially in Ethiopia. There is not enough investigation for conflict conflict type prediction, especially in machine learning. To address the limitation of these research gaps of the above researchers, this study has utilized 413 datasets with 15 attributes, and also 5 algorithms are applied for this study. According to the algorithm, with the leading predictive is to be chosen for demonstrate conflict types. When it comes to the methodology, data collected, that is the data, that's 413 data set with 15 attributes has been taken from armed conflict location and event data from this organization. The data sets, the riots or protests data were 143, that is, which means 34.62% of the total data set, and the battle is 137 data set, which means 33.17% of the total data set, and 133 or 32.2% of the data set is violence against civilian. Data pre-processing, which are handling missing value, encoding, normalization, feature selection has used in this study. Those are the attributes that has used for this study. When it comes to the system design and architecture, this study has used design science research methodologies that prefer design science research methodologies. Data is taken from the armed conflict location and event data that occurred conflict and protest data sets, and then after taking the data set, the data pre-processing is applied, handling missing value, encoding, normalization, and feature selection are applied for this study. Accordingly, after the pre-processing, the data is split for training data set, and the data set finally evaluate and select the best model based on.
Is there someone from the side of the organizing committee, the technical support?
Researchers.
Yes, sir, Mr. Dr. Taklu.
In the later work, this study has used 5 experiments based on previous studies, related studies. Logistic regression, random forest, support visualization, nearest neighbor, and name-based algorithms has used in this study. Has used in this study. Compared to the result, experiment result, compared to the result, the random forest algorithm gives better result than other classical machine learning algorithms. When it comes to the conclusion and recommendations, this study concludes conducted in Ethiopia has yielded valuable insight and ultimately determined the random forest model emerges as the most effective model or technique. Moreover, the practical implications of this study are significant. By accurately predicting conflict types, policymakers, humanitarian organizations, and peacekeeper agencies can gain valuable insight into underlying driving of conflicts, allowing them to tailor their intervention more effectively. This can lead to more targeted conflict prevention and strategies, early warning systems, and resource allocation, ultimately contributing to the reduction of violence and the promotion of sustainable peace in Ethiopia. It also serves as a reminder that a predictive model can play a pivotal role in proactive conflict resolution, enabling timely interventions that can save lives and safeguard the well-being of communities in Ethiopia and beyond. When it comes to the recommendation, this study recommended that collaborate with government agencies, policymakers, and also peacekeepers to implement the predictive model as an integral part of conflict monitoring and response strategy. The second recommendation is continuous data is collected, ensuring that continuous data and updates the conflict-related data to improve the accuracy and relevance of the predictive model. To increase the accuracy of the model, the data will be collected. Capacity building, invest in training and capacity building of local stakeholders in machine learning and data analysis rather than traditional investigations to use machine learnings. And conflict resolution in strategy, utilize the insight generated by the study to tailor conflict resolution and mitigation of strategy specific to identify conflict types. And evaluation and refinements. Regularly evaluate and the performance of predictive model and refine them as necessary to adapt to change conflict dynamics. International collaboration, foster collaboration with international organizations and research institutions to further enhance the predictive model and capacity and broaden its applicability. Applicability is one of the recommendation for this research because the collaboration of international collaboration with the organization and the research institution is are best for the new investigation. That concludes that machine learning can available to or available AI or artificial intelligence component for conflict type prediction in Ethiopia. And the recommendation emphasizes the importance of integrating this technology into conflict management and resolution efforts while maintaining the commitment to data quality and capacity building. When we utilize the technology for the same conflict type prediction is better for better investigation, to get better investigation and to get better insight. Then the selected model assists policymakers, peacekeepers, and international organization governments in identifying and mitigating conflicts before they escalate. Thanks. If there is any question or suggestion, you can.
Okay. Is there Muhammad now here? We just heard from the recorded video his presentation, so I think we will not have a bi-directional communication with the presenter. It is not online. And as you have seen, his research is on a conflict type prediction using machine learning in Ethiopia. And he claimed that he used data from armed conflict area. He reported that he has used 413 data set, instances of data set. And this data has 15 attributes or features and 4 classes or 4 classification, which include protests, battles, change territory, violence against civilians, and 4 classes. So to ask questions, someone should be here to respond. So we will finalize our presentation here. So if there is a chance for okay, he is answering through text because he couldn't speak. As you know, he predicted my question that machine learning research needs more data set, and he has used only 413, and that is challenging. And why not more data were collected for this research purpose? He said there is a challenge to get data, but it's good to start with little data you have at hand if you have a challenge of data. Any other question, please? Through text. Okay. He accepted and acknowledged the question that the data set is very small to be sufficient for data for machine learning research. Someone from artificial intelligence is writing a text, so we will wait to respond to. It would be nice if Muhammad could speak, but unfortunately we don't have audio from his side. Okay. Yeah. The question I'm going to ask was raised by someone from Artificial Intelligence Institute side. It would be nice if we could listen to Mesfin Branu's video if we have solved the technical problem.
Good morning, good afternoon, and good evening, distinguished guests and fellow data scientists.
Good.
This project, the Deep Learning for Fast Ultrasound Quality Assessment project, is a collaboration project among IBM, Oklahoma State University, and Prisma Health. Before I delve deep into the research, I would like to create this scenario. Imagine an individual that has been in an accident and rushed to emergency. Upon arrival, there are several tests that the patient is taking. At their disposal, physicians have several tools and procedures that they need to follow. Among these procedures, one critical test exam that need to be addressed is if there is an internal bleeding. The fast ultrasound, focused assessment with sonography in trauma, is typically designed for such purpose to identify the presence of free fluid in the abdomen, which might be an indicative of internal bleeding. At this point in time, all the decisions has to be prompt and efficient. There is no place for error because it's life and death. The fast ultrasound quality determines the outcome of the procedures. So it's really important to have it sound as soon as possible. But unfortunately, the fast ultrasound examination might be up to the standard, satisfying all the requirements, and also shows or displays all the necessary structures for the physician to make a decision. But on the other hand, it might also have no information whatsoever that's useful for the physicians. So our objective is to use deep learning algorithms to identify or classify good quality and poor quality ultrasound exams. The standard quality grading scale varies from 1 through 5. Quality 1 and quality 2 are considered to be poor qualities. Quality 3 through 5 are considered to be good quality. All the exams were labeled based on these qualities. So we have, since our problem is a binary problem, good quality, classifying good quality versus poor quality, we have to relabel the data set so that quality 1 and quality 2 will be poor quality and the remaining will be good qualities. The data collection was taken by Prisma Health. We received 441 exams. Each exam might have several number of videos taken from different parts of the body. And we collected the total of 3,161 videos. From these videos, we took a snapshot at 20 hertz and found 525,000 frames. Now, the labeling were based on the exams. We have to label the videos in the frames. The logic we used is if a video comes from a good exam, then we are going to consider that the video is a good quality. And if the frame is taken from the good quality video, then we consider the frame has the same quality as its parent, the video, as well as the exam. Based on this, when we compare good qualities and poor qualities, we have only 6% of the entire video that were considered poor quality. So there is data, there is imbalanced data, 60 against 94%. First, what we want to do was to clean the data. So some of the frames had some texts in them. So this might be confusing for the model we are constructing. So we have to remove those. So we cropped the image, which was originally 960 by 720 pixels to 512 by 352. We did other augmentation techniques, and also to address the imbalanced data set, we employed random sampling with replacement, which means during training, each batch, we made sure that each batch contains the same number of poor quality and good quality. The training and testing data set, we divide the data into two parts. 85% for training and validation, 50% for testing. These data sets were created randomly. However, we made sure that the proportion of each qualities also reflected in these categories. So the testing set and the training set have the same proportion of the qualities when compared to the entire data set. Instead of creating just one network, we created ensemble. Different networks start with different initial conditions, and also we removed some portion of the data during training. By doing that, by following the Monte Carlo cross-validation process, we created 10 ensembles, each containing 10 models. So a total of 100 models were trained to see the consistency. For measuring the performance of the network, we use several metrics. The common ones are sensitivity, specificity, and accuracy. Since our data is imbalanced, we didn't want to rely on accuracy, because a model can say everything is good quality and still be 94% accurate, because the portion of the data, good quality, poor quality, is 94 to 6%. So we didn't want to rely on accuracy. We want to see spectrum of metrics of performance. The first method we wanted to experiment was transfer learning. Transfer learning, we have a pre-trained model trained on a relevant huge data set like ImageNet. And then that can be fine-tuned on a smaller data set that we have. We used VGG16 and ResNet 50 pre-trained models. Both were trained on ImageNet dataset. Since these models were trained to classify 1,000 classes, and our problem has only 2 classes, good and poor quality, we have to do some kind of adjustment. So we remove the last layers of these models, these pre-trained models, and attach a classifier to them. So now we have 2 ways to train the pre-trained models. The first one is froze the pre-trained models, the weight and the bias of the pre-trained model, and then only train the newly attached classifier. Or we can train everything, all the parameters of the pre-trained model and the newly attached classifier. When we look at the results, when we freeze all the features, the performance is very poor for both the networks. When we train, the training error is better compared to, but the testing error is still very poor. This might be overfitting. It makes sense because the number of parameters for the pre-trained model is too large to our small data set. Another reason is when we compare the 2 images that the pre-trained model was trained and also our data set, they are completely different. So what has been trained on ImageNet may not be a good fit for our type of data. So we had to create our own network. We started with autoencoders. Autoencoders have 2 parts, the encoder part and decoder part. The encoder part tries to compress the data and create a representative of the input space. The decoder part, on the other hand, tries to use that compressed code and try to recreate the input. In doing so, this model will create a very efficient representation of the input at the input, which is called the code. Now we used the output of the encoder and pass that output through classifier, and we train only the classifier part. In doing so, we hoped we achieve a very good result. I want to mention here that the advantage of using autoencoder is multiple. One of which is we wanted to prevent overfitting. If we were to use only a classifier and we apply the input, the frames as an input, we have just, for one frame, we have just one input. But if we use autoencoders, autoencoder tries to feed every pixel by pixel. So every pixel is an input. So that increases our data set for the encoder part, which prevents overfitting. Now, after training and getting reasonable results on the autoencoder, we use the output of the encoder and attach to classifier. We train on the classifier part. When we look at the result on individual frames, it's not that much significantly big, but excuse me, it has been consistent. We tested on all hundreds of the networks, it has been consistent. Then we used a logic to classify the video. Now this is the frame level. So at video level, we use this logic where if at least 50% of the frames in a video are classified as poor quality, then we are going to say that the video is poor quality. And also the same logic applies from video to exams. If, for example, if at least half of the videos in one exam are classified as poor quality, then we're gonna call the exam a poor quality, something like that. By using this logic, the error significantly improved. The performance is significantly improved. At video level, we have 98% accuracy on average, which is huge. Then we use the same logic for the exams, and we were able to find 100% accuracy. So now this doesn't mean that there were no misclassifications. There were some. But when we look at video level, the misclassified frames were dispersed on the entire videos. So there is no, there are few that are accumulated in one videos, which becomes a misclassified video. But when it comes to exams, there were not enough misclassified videos within an exam to consider the exam as a misclassified one. So we tested all 10 Monte Carlo trials. We found that there were no misclassification in terms of the exams. We learned that autoencoders show a very good result. And also, we learned that the deep learning model learned something from the frames that helped the model to determine the quality of the entire exam. In the future, as a future work, we would want to create some explainability techniques and explain, since this is a medical field, it's very important to explain the results. So we will be working on explainability techniques of this ultrasound classification. This paper was published and selected to be presented at the American Institute of Ultrasound in Medicine Journal Club. Thank you very much.
Okay. Do we have Mr. Muslim with us? No? So we had a nice presentation, re-recorded video of the presentation by Mr. Muslim from IBM Oklahoma State University, USA. And I think he's a senior data scientist at IBM. And he has presented research with the title Deep Learning for Fast Quality Assessment. I think FAST stands for Focused Assessment with Sonography in Trauma. And he has made it a thorough experimental research and presented his results with many experimental scenarios. And we would like to say thank you for the presenter. And that is the end of the morning session. Thank you, everyone, for your attention and attending the presentation. We will meet after lunch, I think, for the rest of the presentations. Is there anyone from the artificial intelligence side to say something?
Thank you, Doctor. Yeah, as you said, we will continue our presentations after the lunch break. Our next presentation will be, yeah, 2 p.m.
2 p.m. It starts 2 p.m., right?
Yes, yes, sir.
So have a good time. For the morning session, we have successfully accomplished our task, right?
Yes, yes, we
All
have.
right. And then
We'll be back at 2 p.m. 2 p.m. Yeah.